Power piping plays a crucial role in the operation and performance of various industrial systems associated with power generation systems. These systems involve the transportation of steam, compressed air, and other high-pressure fluids necessary for power generation, manufacturing, chemical processing, and more. Properly designed and installed power piping systems are essential for ensuring safety, efficiency, and reliability in industrial facilities. In this article, we will delve into the significance of power piping and explore the key considerations in its design. ASME defines power piping as the piping which is found in electric power generating stations, industrial and institutional plants, geothermal heating systems, and central and district heating and cooling systems. The power piping system is designed based on the ASME B31.1 code. Power piping is the backbone of numerous industrial processes that heavily rely on high-pressure fluids. Its significance can be highlighted in the following areas. Power generation. In thermal power plants, power piping carries steam from boilers to turbines, facilitating the generation of electricity. It also transports various cooling fluids in nuclear power plants. Manufacturing. Industries such as steel, cement, and paper rely on power piping for compressed air, steam, and other high-pressure media that drive machinery and equipment. HVAC systems. In commercial and industrial buildings, power piping circulates high-pressure fluids to manage heating, ventilation, and air conditioning systems. The design of power piping systems demands meticulous planning and adherence to the ASME B31.1 code to ensure safety, longevity, and optimal performance. Below are the key considerations to take into account during the design phase. Code compliance. Power piping must comply with international standards such as ASME B31.1. These codes define design, construction, inspection, and testing criteria to guarantee the integrity of the system. Material selection. Choosing the right materials for power piping is vital. Factors like fluid type, pressure, temperature, and environmental conditions impact material selection. Common materials include carbon steel, stainless steel, alloy steel, and non-metallic materials like plastic and fiberglass reinforced piping. Stress analysis. Conducting pipe stress analysis is critical to ensure that the piping system can withstand operating conditions and potential transient events without failure. Advanced computer simulations help engineers identify stress concentrations and ensure proper support and flexibility. Safety measures. Implementing safety features such as pressure relief valves, rupture discs, and pressure regulators mitigates the risk of overpressure incidents, safeguarding personnel and equipment. Welding and joining. The welding and joining processes must adhere to industry standards to maintain the structural integrity of the system. Skilled welders, non-destructive testing, NDT, and rigorous inspections are essential for secure connections. Corrosion protection. High-pressure fluids can lead to corrosion, reducing the lifespan of power piping. Employing appropriate coatings, cathodic protection, or using corrosion-resistant materials can minimize this risk. Expansion joints. Power piping systems experience thermal expansion and contraction during operation. Incorporating expansion joints accommodates these movements and prevents excessive stress on the piping components. ASME B31.1 is the main code that is followed for guidelines of the design, material selection, testing, and construction of power piping systems. There are many other codes, standards, and specifications that are followed to properly design each component of the power piping system. Table 126.1 to 1 of ASME B31.1 lists all such codes. Some of the notable codes and standards associated with power piping are listed below. The major general differences between power piping and process piping are provided in Table 2 below. If you are looking for major differences between the power piping code, ASME B31.1, and the process piping code, SME B31.3, then you may click here. Power piping forms the lifeline of various industrial applications, enabling the transportation of high-pressure fluids critical for power generation, manufacturing, and chemical processes. The proper design and implementation of power piping are essential for maintaining safety, efficiency, and reliability in industrial operations. Engineers must pay meticulous attention to code compliance, material selection, stress analysis, safety measures, welding, and corrosion protection during the design and construction phases. By doing so, they can ensure that power piping systems function optimally and safely, contributing to the smooth operation of industrial facilities worldwide. If you wish to dig deeper and learn more about elements of piping design and engineering, then the below mentioned online courses will help you to do so. The online course